Good evening, student. I am Kamlesh. So for the last class, we have already discussed about the transcendental function. So today I am going to discuss with you piecewise functions. Okay. So let us start with piecewise function. So piecewise function, it has five types. First is modulus function. Next is signum function. Next one is greatest integer function. Next, fractional part of x. And next one is least integer function. Okay, so for in today's class, we have discussed about in this type of functions, discuss their graph with domain and range. Let us start with modulus function. It is also called absolute value function. Okay, so the modulus function, which is defined as fx equal to mod x and mod x. It means it has two values, x when x greater than equal to 0 and minus x when x less than 0. Okay. So the graph of modulus function, which is true as that. Okay. So this is the graph of modulus function. So according to this graph, by looking at this graph, what else we can say? Here we see this is symmetric. The graph is symmetric about y-axis. It means it is even function. It means it is even function. And also for this graph, here we see the domain x belongs to R because our curve which is lies between all R and about the range. So the range y belongs to 0 to infinity. Okay, because our curve which is open upwarded side, so that's why here range y belongs to 0 to infinity. Okay, so in modulus function there are some important property which is helps to find the domain. Let us discuss the properties of modulus function or absolute value function. Okay, so the first properties which says if x square, see x square less than a square. So it can also written as mod x which is less than a and mod x. It means it has two value. So minus a which is less than x less than a. So here x belongs to open interval minus a to plus a. Okay. Then for second case, x greater than equal to a square. So mod x which is greater than equal to a, it means minus a which is less than equal to x less than equal to a. So here x belongs to close interval minus a to plus a. Okay. And for third case, when x greater than equal to a square, sorry, not equal to, only x greater than a square. So mod x which is greater than a square. So here we see when x greater than a and also minus x which is also greater than a. So here we write x greater than a and x minus less than or minus a. So it can be written as x belongs to minus infinity to a in open interval union of a to infinity. Okay. Then for the fourth case, when x greater than equal to a square, it means mod x which can also written as greater than equal to a square. So x greater than equal to a and minus x greater than equal to a. So this implies x greater than equal to a and x less than equal to minus a. So which is equal to, where x belongs to minus infinity to minus a but in closed interval. Okay. And union of a to infinity. Infinity is always written in open interval. Okay. So go for the another type of property. See, if we have two elements like a square less than x less than b square, so it can be written as a less than of mod x less than b. It means a less than x less than b. Then what about the minus? Then here minus b less than x less than of minus a. So which implies here x belongs to minus b to minus a in open interval, then union of a to b in open interval. Okay, this is first case. This is another type of property. Here two elements include like a and b. Then second, if a is less than equal to x less than equal to b square. So this implies it can also written as a less than equal to mod x less than equal to b. It means a less than equal to x and less than equal to b. Again, minus b, which is less than equal to x and less than equal to minus a. So this implies here x belongs to, but see here symbol is less than equal to. It means it is written as close interval minus b to minus a in close interval union of a to b. Okay. Now we go for the third case. It means a less than equal to x and only less than b, not equal to. So this implies a less than equal to mod x and less than b. So a less than equal to x less than b and minus b, which is less than x less than equal to a. So this implies here x belongs to minus b in open form, minus a in closed interval, union of a closed interval and b in open interval. Okay. Then next one is fourth case, when a less than x but less than equal to b square. So it can be written as a less than mod x, which is less than equal to b. Then a less than x less than equal to b and minus b less than equal to a less than a. So this implies here x belongs to in closed interval minus b to minus a in open interval, union of a in open interval and b is in closed interval. Okay. And third one, there is important result. Okay. So first result, say if mod of x plus minus y, which is always less than equal to mod x to plus mod y, and when mod x plus minus of y, which is greater than equal to always when x minus. Okay, so these are some important properties of modulus function. Then we go for the signum function. Okay, so the signum function, which is defined as fx equal to x divided by mod x when x not equal to 0 and 0 when x equal to 0. See here, it is a piecewise function. So here we write mod x. It means first we write x when x greater than 0, x divided by minus x when x less than 0 and 0 when x equal to 0. Then solving this, we have 1 if x greater than 0, minus 1 if x less than 0, and we have 0 when x equal to 0. So this is a signum function and the graph of signum function. See, like this. This is point 1. This is point minus 1. Okay, and 0. 0 is already here. So See, this is the graph of signum function. So here we see that domain, here domain x belongs to R and range y belongs to, we have value here 1, 0 and -1. So these are the domain and range of signum function. Now next one is greatest integer function. Greatest integer function. Okay, so greatest integer function. So in this function, it can be written as like this form. Okay, this is a closed interval, but here the value of x, which is very nearest or smallest value of x. Actually, this is the form of n less than x less than actually less than n plus 1 form. Suppose we have any element like greatest integer in 2.3. So what we have value here? 2. Suppose if we have value here 0.23, then the value of greatest integer value here, which is 0, when it is 2, then it is equal to 2. Okay. Now I construct the table which is easily understand the concept of greatest integer value. Suppose here the value of x and the greatest integer of x. So suppose here 0 less than equal to x less than 1. So the value of greatest integer function here 0 less than equal to x less than 1. The value is 0. When 1 less than x less than 2, the value is 1. Then 2 less than equal to x less than 3. It means the value is 2. Suppose we have any negative number like -1 less than equal to x less than 0. So we have -1. And if -2 less than equal to x less than 1, then the value is -2. Okay. And the graph of greatest integer function C, it is drawn as like that. First we mention the point. -1, -2, -3 and -4. See the graph of greatest integer like this. First we dotted here this line like this. Okay. Now next one is 2, 2. It means like this. Now next one is 3, 3. Okay. See. Now here this is the point of -1 to 1 like this. Next one is -2 to 2 like this. Next is like this and so on. Okay, so this is the graph of greatest integer function. Now we go for fractional part of x. Fractional part of x. Okay, so the fractional part of x, it is defined as like that, and it is also written as like x minus of greatest integer of x. Okay, here we also construct a table, understand the concept of fractional part of x like this. Okay, suppose we have a value x. Okay, if we started with 0 less than x less than 1, then the fractional part of as here x. Okay, when we write 1 less than equal to x less than 2, it means here the fractional part like this form x minus of greatest integer of x. So here we write x minus 1. When we go for 2 less than equal to x less than 3, so x minus 2. Okay, when we go for the negative integer, it means -1 less than x less than 0. It means this is a x plus 1, right? Now next one is -2 less than equal to x less than -1. So which is x plus 2. Okay. Now we draw the graph of fractional part of x. See, this is the point 1, this is the point -1. But here the graph which is lies between like this. Okay, now mention the point 1, 2, 3, 4, 5. So here, first is like this. Okay, this is x. Now next one is 1 less than equal to x less than 2. It means like this. This is the graph of x minus 1. Now next one is x minus 2 and next one is x minus 3 and so on. Okay, now for the this side. So this is x plus 1 and next one is x plus 2 and so on. Okay, so this is the graph of fractional part of x. Okay, when we go for the last piecewise function, which is list integer function. Okay, so for the list integer function, it is also denoted as like as x. Okay, but here one thing we remember, when we have an element like 2.3023, so the list integer is here 3. Okay, when we have 0.23, then the least integer value is here equal to 1. Okay, when we go for minus 8.07, so the list integer function here minus 8. Now here we also construct a table, understand the concept of list integer function. Okay, this is x and this is list integer function. Suppose we have minus 1 less than, actually here only write minus 1 less than x less than equal to 0. Then the value is 0. When we have 0 less than x less than equal to 1, the value is 1. 1 less than x less than equal to 2, the value is 2. Then minus 2 less than x less than equal to minus 1, then the value is minus 1. And minus 3 less than x less than equal to minus 2, the value is minus 2. Okay, now we go for the graph of list integer function. So the graph of list integer function, see like this. 1, 2, 3, 4. First mention the point. Minus 1, minus 2, minus 3 and minus 4. Minus 1, minus 2, minus 3 and minus 4. Okay. So here the graph like this. Okay. Like this. Just opposite way. Okay. Okay. This is mentioned. Okay. So this is the graph of list integer function. So for today class, to summarize for today class, we have discussed about the piecewise function and also discussed about their types like modulus function, signum function, greatest integer function, fractional part of x and list integer function. Also we discussed about their graph and domain range. Thank you.